Hello class, we're going to do some problems here from section 5.5a. So here's one integral we're going to try to do: 4 sine cubed of 2x times cosine of 2x dx. So if we look at the integral formulas, we definitely don't have a direct integral for this. We have to use a u substitution. So I'm going to see if I can let u, let's see, a lot of times you let u just be the angle, but that's not going to really help us. What I notice is I have sine raised to the 3rd power of my angle. So what if I let u be the sine of my angle 2x? If I try that, then the derivative du, well, the derivative of sine is cosine. So that would be cosine of the same angle 2x, and then of course times dx, the derivative of 2x is 2. So let's see how that's working. I definitely have sine of 2x all cubed, so I definitely have u cubed. I've got the cosine of 2x, right? And here, when I think about it, well, I definitely have 2. Actually, I have too much here. So what I'm going to do to make this 4 into a 2 is you divide, right, or multiply by a half. And if I do that to compensate, I put a 2 out in front. So I have a 2 out in front. And then that 1/2 times 4 is 2. So I have exactly the right du. I have 2 cosine of 2x dx. That's good. So I've got 2 outside times the integral of u cubed du. Everything's set up right. Now I can integrate. Just raise your power. Don't forget the 2 out in front. So this is u to the 4th over 4, right? Plus your c. 2 into 4 is 2. So I end up getting u to the 4th over 2 plus c. Don't forget to plug back in for your u. Your u was sine of 2x. So what I really have here is 1/2 times sine to the 4th power of my angle 2x, and then plus c. And there you go. There's one more that I'd like to try for this little portion. Kind of a little tricky as well, and that is the integral of the tangent of x dx. Well, looking at this, again, if I look at those formulas, I don't really have a direct integral here for the tangent of x. But if I rewrite it, and remember that tangent is sine of my angle over cosine of my angle. This might help me out. Let's take a look at this. If I let u be the cosine of x, the derivative of cosine is negative sine of my x, right? Look at what I have. I mean, I have u in the denominator. I have sine x up in the numerator. I want it to be negative. So again, pull another negative out to compensate. And so really what I have is negative, and then this would be du, which is negative sine x, over u. And du over u, that integral, that's that natural log. It's in your formula sheet. So really what I have is negative in front, and then the natural log of u, right, plus my c, and replace that u back with cosine of x, so it's negative natural log of the cosine of x plus c. And if you want to, this is okay, but if you want to pull that negative back up, remember there's a natural log rule that would say that you'd have cosine to the negative 1 power, which is really secant of x. So this becomes natural log of secant of x plus c. And again, if I put that -1 power back up, that rule of natural logs, the cosine of x, the reciprocal, or cosine of x to the -1 is really just the secant. So this, maybe it looks a little bit more neat and tidy. Either way is really correct though. Alright, this last group of problems are kind of a little bit tricky, but still from section 5.5, part A. So let's take a look at this one. Again, you know, when I see x minus 3 raised to the 4th power, I'm thinking that I'm going to let my u equal that x minus 3. And when you take du, you just get a 1, right? So just 1 dx. Well, I've got dx. That's not the problem here. But what's going on is I have an extra x in there. It's an extra variable. It's not like I can just divide out a variable. So I have to figure out some way to represent that x. And what I'm going to do is look at my u equals x minus 3 and solve this for x. So if u is x minus 3, I can say, all right, add 3. I could say that u plus 3 has to equal x. I just added 3 over here. So this is true as well. And now let's see if that helps us out. So I've got my integral. In the numerator I have x, which is really going to be u plus 3 over, and then in the denominator I've got u to the 4th power. And then of course I've got my du. This I can work with. I can separate it up. So this is really going to be the integral of u to the -3, right, plus 3u to the -4 du. And that's something I can work with. Let's just raise the power. Take our integral now. That's going to be a -2 over -2 plus 3. We're going to raise this power by 1. That'll give us u to the -3 over -3. Let's just go ahead and replace my u back with x minus 3. So this one is going to end up being a -1 over 2 times x minus 3 squared. That was in the denominator. The 3's cancel here, and that leaves us a -1 over x minus 3 cubed, and then plus c. So there's our solution for that first one. Again, the trick is there was an extra x in there, so I had to use my u equation to solve for x, so I'd have something to plug in for that variable x. Let's try another one. Here I have the integral of x times x plus 2 raised to the 3rd power dx. Alright, so I'm going to let my u be what's being raised to that power. U is x plus 2, and du would really just be a 1 dx. So again, I've got u cubed. I've got the dx, that's no problem there. But I have x in the way, another x, a variable in the way. So use your u substitution. If u is x plus 2, that means that u minus 2 has to be x. Just subtracting 2 to solve it for x. And now I have something to plug in for x. Alright, so I have my integral. X is u minus 2. And then I have u to the 3rd power, u cubed. And then I have my du. I can now distribute u cubed into this parentheses. Right? That's going to give me u to the 4th minus 2u cubed when I distribute. And this is something I can integrate. Just using my power rule, that's u to the 5th over 5 minus the 2. This will be u to the 4th over my 4. Okay. Let's replace u with x plus 2. So it's x plus 2 to the 5th over 5 minus, this 2 cancels into the 4, and this will be u to the 4th, so our x plus 2 to the 4th power over 2, and then don't forget your plus your constant. And we were able to do it. So again, at the beginning, our problem, we couldn't distribute the x in here because of the power, and we had that extra variable, that extra x. So use the u equation to solve for x, and then we have something to plug in. Let's try one more problem of this type. So we have the integral of x times the square root of x plus 3 dx. I'm going to try and let my u be what's under that radical. So if u is equal to x plus 3, I know that the derivative of that is just 1 dx. I notice again, the problem is that extra x, the extra variable there that I have to plug something in for. Solve for x with the u equation. So this means that u minus 3 is x. And we'll plug this in for the x. That's u minus 3. And then I have the square root of my u. And remember, the square root just means u to the 1/2 power. I'm going to rewrite it. And then du. I can distribute the u to the 1/2 in here now. Let's see what we have. That's going to be u to the 3/2. You're just adding those exponents. Minus 3 u to the 1/2 du. And now we can take our integral. Raise the power. That's going to give me 5/2 times the reciprocal, 2/5. All right. Minus 3 times u to the 3/2. And again, multiply by that reciprocal, 2 over 3, plus my c. And let's see what we've got. So I have 2/5. My u is x plus 3, so I'll say x plus 3 to the 5/2. Here the 3's cancel. That's just going to leave me minus 2. Our u is again x plus 3 to the 3/2 power, and then plus c. And there we've done it.